What's up, guys? It's Mr. Escobedo. I'm here to explain that I'm going to go over our study guide on Newton's three law of motion, okay? So you guys should have this out with you right now, digitally or on paper. And I actually made a PowerPoint just like the last time we had a study guide. And it looks like this, okay? So follow along. So make sure you have this out. So tomorrow is your test, right? And you want to be prepared for it. So what are Newton's laws of motion? So there's three of them we learned so far, right? An object at rest will stay at rest, and an object in motion will stay in motion until an unbalanced force acts upon it. So that's what I would put in law one. And you'd also make sure you have that hint of inertia. And if you don't know what inertia is, on the bottom of your study guide, it is one of the terms you should know. All right. Number two, accelerating an object with a large mass requires a large force. Accelerating an object with a small mass requires a small force. And our formula, our golden formula, is force equals mass times acceleration. And I also put images here. This PowerPoint will be available for you guys if you need to review. And last was our new and our final law, which was law 3. For every action, there's an equal and opposite reaction. Newton's cradle. All right? So while we're getting ready, just make sure that you're also keeping in mind that the key terms for each one of them. Yes, Newton's third law can, mix with law 1 and 2, but really try to space out which examples are for which. So let's go into some of the practice questions. So here we have the practice, which our directions are which of Newton's laws is applied to the examples, right? First, second, and third on the line. And in this one, in the PowerPoint, I actually put each response and why. So a rocket flying up into space, the flames blowing down as the rocket moves upward. It's one of our examples that we use in which one? Let's think. Opposite reaction, right, guys? So the third law should be for A. A paper bag laying on the desk, but then you open a window and the paper blows away. So something at rest remained at rest until an unbalanced force disrupted. So it is Newton's first law, law of inertia and unbalanced forces. C. Moving a refrigerator takes a lot of force, but lifting a microwave takes less force. This is answer second law. Force equals mass times acceleration. D. Could look a little complicated, but it isn't. A bird flapping its wings downward, but flies upward because of the wind, is Newton's third law because of the opposite direction of where it takes flight and where it pushes off. All right? E. This law is also called the law of inertia. The answer is Newton's first law, law of inertia and unbalanced forces. When a car crashes, your body continues to move forward, but the seatbelt holds you back. This is our very first topic we talked about when we spoke about Newton's first law, which is the law of inertia and unbalanced force, and something in motion will stay in motion. So Newton's first law. And lastly, when you row the oars on a canoe, pushing the water behind the boat, so oars are pretty much those paddles, right? But the boat moves forward. This is Newton's third law because you are actually riding and going the opposite direction, pushing yourself forward. All right, we're almost done here, guys. So terms to know. Make sure you know what acceleration, inertia, and friction are. They're all in all of our laws, but make sure you review that because tomorrow's test will need you guys to list these examples, write Newton's first, second, and third law, and I believe that you guys can actually do this, all right? So please get some rest. And hey, I believe in you guys, all right? Good luck, good luck, good luck. Oh, and The reason I'm out for today is not because I'm sick or anything, just because I had to go get checked at the doctor for my knee thingy. So just, hang in there. I miss you guys. I wish you guys the best. Take it easy, all right? Peace.